Hello students, welcome back to the next module. And this module will continue with MCQs on simple pendulum. So let's start with our first question. A simple pendulum completes 10 oscillations in 30 seconds. Another simple pendulum takes 40 seconds to complete 10 oscillations at the same place. Place is same, that means G is constant in this MCQ. The ratio of the length of the simple pendulum is, and 4 options are given to us. Now how do you solve this question, students? G is same, that means G is constant here. I have to find L1 upon L2, ratio of the length. So if G is constant and if I want to find L, the only formula that strikes our head is T proportional to root L. Now the only challenge is how do you find time period in this question. Now for this the hint is in the first line which says 10 oscillations require 30 seconds. So let's write down 10 oscillations require 30 seconds. Students, now how do you find time period? We know time period is time taken to complete one oscillation. So if 10 oscillations are taking 30 seconds, one oscillation will take how much time? That is T1 is equal to, let's cross multiply them and we get 30 upon 10, that is nothing but 3 seconds. Now the second pendulum takes 40 seconds to complete 10 oscillations. Following a similar calculation, T2 will be, students, 40 upon 10, that is nothing but T2 is equal to 4 seconds. Now, as we know T proportional to root L, therefore T1 upon T2 is equal to root of L1 upon L2. Now, squaring on both sides, let's arrange the answer in terms of ratio of length, that is L1 upon L2. Therefore, I write L1 upon L2 is equal to T1 upon T to the whole square. T1 is 3 and T2 is 4. Therefore, our next step becomes that is equal to 3 upon 4 the whole square. 3 square is 9 and 4 square is 16. Therefore, we get the answer L1 upon L2 is equal to 9 upon 16. That is nothing but our option A. So the right answer for this MCQ is option A, 9 upon 16. Students, in this case, time period was given in a very coded language by giving the information 10 oscillation in 30 seconds. From there we found out D and we solved this MCQ. Let's move to the next question, students. If length of the simple pendulum is increased by 1%, its time period will increase by 1%, increase by 0.5%, increase by 0.5% and decrease by 1%. Students, first of all we need to understand. We know T proportional to root L. Now in this case, length is increasing. As T is directly proportional to root L, if L increases, time period will obviously increase. Therefore, option B and option D are wrong, which says decreases. The answer has to be either option A or option C, that is both of increase option. Now, students, one more important thing. If I solve this by traditional percentage method, as I did in the last module, since the percentage change is small, that calculation will be very difficult in entrance exam. Therefore, if percentage changes are small, we have a shortcut method to solve this type of problem. Now, let's go for it. As we know T proportional to root L, root means raised to half. I immediately write T proportional to L raised to 1 by 2. Now see how do I write this? Now I express left hand side in terms of percentage change. That is I write therefore delta T upon T, that is change in time period, upon original time period, which is nothing but percentage change in time period, is equal to, take that power ahead and I write half delta L upon L. That means overall change in percentage change in time period is half of percentage change in length. Now let's substitute the values. So delta T upon T will be half, and students, percentage change in length is already given to us. Length increases by 1%. So directly write here 1%. If I cancel this, half of 1% is 0.5%. Therefore, I write percentage change in time period is 0.5%. Now, as I told, T is proportional to root L. If L increases, obviously time period also increases. Therefore, the correct answer is time period increases by 0.5%. That is nothing but option, yes, option C. So student, in this MCQ, we saw a very important shortcut to solve the question, but we should use it only when the percentage change is small. That's all in this module, students. See you in the next one.
इस तेरा आवाज है और इस चूती का आवाज है और किसी आवाज
खत्म हो गया
अब भी खत्म हुआ।